Solution of simultaneous equation. As Jacobi's method and Gauss-Seidel methods are two iterative methods which we are used to solve the solution this simultaneous system of equation. As in iterative process, we know we carry some process to find results, and using that results we can again do the same process to find new results which are improved result or which are close to the accurate roots or accurate results of given system. Now in this methods, as we have given three equations containing three unknowns, as this is the equation number 1, as we can draw x from this equation by taking the terms of y and z on right hand side, as there is a constant d1. By taking the term of y, the change the sign, as it was plus on left hand side, so we take minus, so minus b1y. Also similarly, term of z on left hand side, right hand side we get minus c1z, and the coefficient of x a1 take in denominator, as it is in multiplication of x, so we on right hand side it will be in denominator. So we get value of x as a d1 minus b1y minus c1z divided by a1. Similarly, from equation number 2 we can find another unknown y, as y is equal to, on right hand side, as the constant d2 is there, the term of x will be transferred and term of z will be transferred. So we get the y as a d2 minus a1x minus a2x minus c2z divided by coefficient of is y is here b2. Now we can similarly find the value of z here also, that is z is equal to d3, that is constant of equation, minus term of x, that is a3x, and term of y minus b3y, and divided by coefficient of z, that is here c3. You can easily find these values from unknown from each equation, as in equation 1 we get value of x, from equation 2 we get value of y, in equation 3 we get value of z. As you can understand here, the value of x are in term of y and z. Similarly, value of y is in term of x and z, and similarly and last z value of z is now in term of x and y. If we know y and z, then we can find value of x. As we know x and z, we can find the value of y, and in last case, if we know value of x and y, then we can find value of z. So these two methods are the numerical methods, in which we first assume some values for x, y and z. If we assume value of x and value of y and value of z is equal to 0, then the method is called Jacobi's method. As by using value of x, y, z is equal to 0, that means to find value of x we take y and z as a 0, to find value of y we take x and z is equal to 0, and to find value of z we take x and y as a 0. So to find x we use this equation. Now we call this as a equation 1, which is a value of x in term of y and z, which drawn from equation number 1 from given system of equation. As equation 2 is value of y and equation 3 is a value of z. So find value of x, we have to use equation number 1, in which we have to put y and z as a 0 0. So we get the value of x as x naught, which is the initial root. Similarly, the value of y will be y naught by taking x and z as a 0 in equation number 2, and in last equation we put value of x and y as a 0 to get value of z, which will be z naught. These are initial roots or first approximate roots. If they are the roots, that means these values satisfy the given system of equation, then we stop the process. If these are not the root of given system of equation, then we continue the process. Okay, for that we take second iteration. Now the value of x will be x naught, value of y will be y naught, and value of z will be z naught. As you understand here, to find x we take y and z as y0 z0 in equation 1, so we get value x1. To find value of y in equation 2, we get x as a x0, z as a z0, so we get value of y as a y1. And to find value of z, we use equation number 3 by taking x as a x0, y as a y0, and to find and evaluate the value of z as a z1. Now these are again new set of roots of approximate roots of given system of equation. If these are the roots by which satisfy the system of equation, then we stop the process, or we continue the process to find next set of approximate roots x2, x3, x2, y2 and z2. Okay, x2, y2 and z2. For that, in this system, in this equation 1, we use y as a y1, which we have evaluated, and z as a z1. To find y, we use x as a x1, y and z as a z1 to find y2, and you can similarly evaluate the value of z as a z2 by using equation number 3 by putting x as a x1 and y as a y1. Now this is again set of new approximate roots. As if they are roots, then we stop the process, otherwise we continue the process. Okay, actually the process will be stopped when the successive set of roots are equal. Generally, as you can understand here, in first iteration we have find the values of x as x0, y0, z0. In successive, that means second iteration, we have value find x1, y1, z1. If x0 is equal to x1, y0 is equal to y1, z0 is equal to z0, that means all three values are equal to their corresponding values, successive values. Then we stop the process generally. If one of them is not equal, then we continue for next iteration. As if second if we take third iteration to find value of x2, y2, z2, if x1, x2, y1, y2, z1, z2 are equal, then we stop the process. That means we get the root of the system. If one of them is not equal, then we take another iteration. So carrying such a repetition of process to improve result, so is it called iteration process. So Jacobi method is a iteration process. Now in Gauss-Seidel method, what we do, actually in Gauss-Seidel method we take as a y and z equal to 0. Now remember, as in Jacobi's method we take all three unknown as a 0, but here we take only y and z is equal to 0. As using this value, we can find the value of x from equation 1 as a x0 by putting y and z is equal to 0. Now this x0 is equal to, we take as a x, and as we define z as a 0, by putting this value in equation 2, we get value y0. Do you understand? By taking x as a x0 and z as a 0, we get y0. Compare with Jacobi's method. As to find y as a y0, we take x and z both 0. That means we assume value as x, y, z is equal to 0, and using these values we find x0, y0, z0. But in Gauss-Seidel method we only assume y and z, so we can find x only, which is a x0. Now to find y, we want value of x, which we have calculated as a x0. Use it in equation 2, as we assume z as a 0, we get a z y0. Now to find z, as we define x as a x0, what about y? As we have two values of y, one which we assumed as a 0 and one which we have calculated as a y0. So take calculated value, that means take y as a y0 to find by putting them in equation 3, we get value of z as a z0. So we have now three values x0, y0, z0, which are our approximate root for first iteration. Okay. Now using them we can find next set of roots x1, y1, z1 in second iteration. Now to define second iteration, we take as y as a y0 and z as a z0. Again, we don't take here value for x. Now using these values in equation 1, we get the next approximate root as x1. Now to find value of y1, as we take x as a x1 and z as a z0. Okay, and z1 in from equation 3 we use as x as a x1 and y as a y1. Yes, which we calculated. So x1, y1, z1 are again new set of roots, approximate roots. If x not equal to x1, y not is equal to y1, z not is equal to z1, then we stop the process. If any one of them is not equal, then we continue for third iteration. For that, in Gauss-Seidel method, we assume two values first as y as a y1 and z as a z1 to find x2 from equation number 1. Okay, and say using this x2 and z is equal z1, we find value of y2. And now using x2 and y2 in equation number 3, we will find the value of z2. Now new set of roots are x2, y2, z2. If x1 is equal to x2, y1 is equal to y2, z1 is equal to z2, then we stop the process. If one of them is not equal, then we carry third iteration to find x3, y3, z3. For that we use value of y as a y2, z as a z2 in equation 1 to find x3, and continue the same process to find y3 and z3. This is called Gauss-Seidel method. So remember the difference between these two methods.